Hi, good morning. Can you hear me? Does it work? All right. So my name is Lian Lim, and I'm here actually giving this talk on behalf of Harry Ferguson, who couldn't make it to this conference. So it's about JWST Python analysis tools, but really the analysis tools are mostly instrument agnostic, so you can really use them for your research as well if they apply. So the motivation behind our work in the data analysis tools branch is to enable science. If you need rigorous analysis, robust, fast, we are trying to enable you, help you do science. And we try to provide common tools for cross-mission, observatory, or discipline to do some really common things like convert units, combine images, spectra, and so on. So to avoid duplicating effort in the field, like you don't have to all write your own, say, image combination function. And we are trying to also provide quality tools, so not only to duplicate to minimize code duplication, but also document it so you know how to use them, write some tests so you know if they are working fine, trying to be user-friendly so you don't like cry when you use them. So that's our goals, the motivation. So as you can see in the picture, the data come down as like 0 and 1s, and with our tools, you can actually turn them into something more meaningful and eventually write a paper and become famous. So here's some tiers and dependency in the tools that we develop. So at the lowest level is the language itself. Mostly we work in Python, but occasionally we also dabble in C when we have to. On top of that, we use some common libraries out there as listed. The ones that are gray out, we don't commit our staff too much to help them, but the ones that are not gray out, we have some money and resources to help out a bit in their development. So AstroPy is one of those libraries that we have stuff to help with. And on top of those libraries, we have visualization tools, Glue, DS9, Ginga. And on top of those, then we have the data analysis tools, both visual and command line kind of things. So here's, I'm not sure what you call this balloon thingies. Venn diagram, right? Sorry, I haven't gotten enough sleep lately. So here's a Venn diagram of the development work in the data analysis tools branch. So AstroPy is its own kind of ecosystem. And then we have JWST, the James Webb Space Telescope, the HST Hubble Space Telescope, and they kind of overlap here and there. So in JWST, we are trying to build use cases right now and try to finalize the data formats. Can you still hear me? Yeah. Okay. So on the HST side, mostly is try to get people away from IRAF to Python. So Stack notebooks is one of the ways we do it. So the link is given. You can actually go to the website and look for yourself. So it's kind of like a conversion guide kind of thing. Like say, I have used in combine for 20 years. How do I now use this in Python? Of course, you will need some mindset change as well. It's not a one-to-one correlation. And if you're willing to make that leap, we have stuff to help you. So to make things easy, we have Astroconda channel. So it's kind of like a one-stop shopping kind of thing. And we mainly use it to distribute public STSCI software. So this line here, conda create -n Astroconda STSCI, basically gives you the software that we developed at STSCI and put it in the Astroconda. All right. I would just use the mic. This. Sorry about that. So this Astroconda channel include, of course, data analysis tools, but we also, that's how also we distribute the Hubble Space Telescope pipelines. And if you really want to, you can also get IRF there, but I don't recommend it. So in the future, we are also hoping to distribute the JWST pipeline this way through this channel. So here's some showcase of some, just a very limited set here. We have a lot more stuff than this for our data exploration and interactive analysis stuff. So you might have heard of Speck Waves from Nick yesterday. So here's is one of the stuff. Fort Utils, I'm sure some of you have used it. Larry in our branch work a lot on it. Im exam, this is a Python replacement of the IRAF Im exam task. Megan Sosi in our branch is the main developer for that one. And CubeVis, I think Nick is also one of the main developers. CubeVis is like a visualization tool for data cubes, which hopefully, if I have time, I will do a quick demo at the end of the talk on Windows. So some goals for JWST, on the JWST side, we want to enable and resample data analysis, build some Python infrastructure to enable rapid development. Say, if you want to write your own analysis code, you can build it on top of what we already have. So you don't have to do everything from scratch. For JWST, we also need to develop a new data format called ASTIF and also support complex WCS that is kind of beyond what FITS WCS can do. So it's called JWCS, and Nadia here is the main developer for that. And I think she can also tell you a lot about ASTIF as well. We also want to build some WIS tools for images and spectra. They will be interactive, responsive, and versatile. And also, we want to build point spread function and line spread function tools as well for JWST. So challenges, I'm sure you have already heard a lot about this from Nick's talk. So first of all, obviously there's no JWST data yet, so we have to rely on what we can get from the simulations. And in order for our WIS tools to be versatile, in addition to JWST and HST data, we also have to handle existing data formats out there in the wild. It can get challenging. Also, transitioning users from their non-Python world can also be challenging. And of course, as you have heard in other talks, spectroscopy tools in Python still needs some work. So we cannot just tell user to stop using this IRAF, spec something, because we really are not ready to replace it in Python yet. But hopefully that will change very soon. And resources is, of course, always a challenge. Time, money, people. So here's just a table to show you our hope between now and 2 years from now. So this is Harry's thing, by the way. I didn't make this. It's good, Harry. So the leaves thing is a prototype stage, and then it will be evolving to Pi when it's mature enough. So hopefully everything in 2 years would be in the Pi level. You will notice that Ginga and ST Ginga will still be in the cherry level, not because it's not as good, but because we simply don't have enough resources in our branch to help them. So in 2 years, it's unlikely it's going to completely replace DS9, but we hope it's going to be at least most of the way there. So here's some JWST documentation. That's the landing page. And if you go to the search bar on the top right and just type, data analysis tools, you will find the sub-page for this post-pipeline data analysis, and hopefully that will get you started if you want to explore what we have and if it could apply to your work. And of course, we are always looking for help. If you want to get involved, most of our stuff, actually, I would say all our public packages are all on GitHub, mostly under Space Telescope organization, Space Telescope, all one word. That's the best place to submit feature requests, bug reports. Feel free to contribute if you can. If you see a bug, you know how to fix it, open a pull request, we welcome that. Algorithm, tutorials. And also, JWST has a data analysis forum sprints. If you're interested to join our sprints, you can subscribe to this mailing list. Like Nick said yesterday, most sprints happen at Space Telescope, but people can join remotely. It's very welcoming. And if you want to use and provide feedback for this number of tools that we have, that also would be very useful, because we don't know what you need until you tell us. So demo time, and I have 3 minutes. All right, how do I get out here? Let's see. Windows, everyone. All right, so just a quick, sorry. So just a quick view. So these pages, I just want to show you they really exist. I'm not just, telling you they are, but they really are. So here's Astroconda website. Here's an example of the Stack notebook. So this one tells you how to do imsurfit in Python. And here's the CubeViz documentation. And for the demo, I would be using a data cube from Manga. All right, so I already have CubeViz loaded here. Works on Windows 7, great. And I have the Manga cube already loaded. So first of all, I want to slide this slider thing to a feature of interest. Say the peak over here around 5,900 angstrom. So as you can see, as I was sliding that thing, the image change in real time. So right here, I can see, the galaxy at this wavelength. And I can change if grayscale is too boring, you can change the color scheme. See, now it's more exciting. All right, so sometimes you don't want to just see one slice. You want to do, say, a sum around the feature of interest. So it's really hard to do this with one hand. I'm going to try 2 hands. All right. Has not crashed yet. This is great. So, all right. So have my region of interest, and then I go to this data processing button and say collapse cube around that region. Just calculate with the default parameters. It says blah 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 info window. Is that click OK? So now you can see this title is a bit different. Flux collapse sum. So it's a sum of the flux in the selected region. And I can also do some arithmetic with this. So I say I want to calculate signal to noise. So I click this new arithmetic attribute, insert flux, times the inverse variance. And I say this is the signal to noise. And say OK. Okay. So now this is the signal to noise for that. I think it's for the region of interest, but ask Nick. So that's my demo. And I have 10 seconds left. Thank you.
Hi, thanks for your talk. So you were mentioning that you want to change fits to ASDF on the long run. Is it just for a space telescope or as a global revolution for everybody, I guess?
It is a general data format, so it's not just for JWST. And I think Stuart might talk to Stuart. Nadia and Stuart. So JWST, I think, won't be the only one that will be using it. The motivation to use it over FITS is the generalized WCS, because if you have weird distortion that you cannot represent in FITS WCS, then you need to use GWCS, and SDIF can work with that.
Nice talk. I had a question about documentation. So you got like read the docs that comes out of the sort of process, automatically building docs that come out of the software, and then we've got JDocs. So how do you decide which is the right place for people to go? Is there some sort of style guide that you're developing for when to use like JDocs, which needs updating by humans, and read the docs, which presumably gets updated as the software is developed? You thought about that?
It is challenges. I should have probably listed on one of the challenges, and we are still trying to iron things out. Just recently, someone found that the installation instruction is not quite right on JDocs as opposed to read the docs. Still trying to figure things out, but in my head, and I'm not speaking for Harry, so Harry might have a different answer for you. In my head, hopefully we would just link to the read the docs from the JDocs. So, you can use JDocs as your quick start or whatever, but all the meaty stuff would be in read the docs. That lives with the code.
Time for a few more questions. Okay, well, let's thank Lian. That was
Thank you.
interesting.